Let's move on to Chapter 4. We will be talking about congruent triangles. There's a long list of vocabulary for this chapter. You should pause the video right now, write out each one of these vocabulary words, and fill in the meanings as we progress. We have three theorems: triangle angle sum theorem, third angles of congruent triangles theorem, and the exterior angle remote interior angle sum theorem. There will also be two corollaries for these theorems. Let's begin by classification of triangles. The acute triangle has three acute less than 90 degree angles. So, with this triangle, each angle will be less than 90 degrees. In the right triangle, there will be one right angle of 90 degrees. You cannot have more than one, and the one should be designated by either a box, like you see at angle C, or the actual degree measure of 90. And the obtuse triangle has one obtuse greater than 90 degree angle. In this example, you'll see that angle M is much larger than the other two angles. Angle M will be more than 90 degrees. We're covering also the equilateral triangle. This is a special triangle, and each angle of the triangle, so angle Q and angle R and angle P, are all equal to each other, are all 60 degree measures, and 3 times 60 equals 180. In the right triangle, the side opposite the right angle is the hypotenuse. So you have angle C as the right angle, and opposite angle C is the hypotenuse. The other two sides are known as the legs. The Pythagorean theorem states that the sum of the squares of the lengths of the legs in a right triangle is equal to the square of the length of its hypotenuse. You know this theorem as being a squared plus b squared equals c squared. In geometry, we actually use this theorem by naming the segments used for the sides of the triangles. So AC squared plus BC squared will equal AB squared. So the long leg squared plus the short leg squared equals the hypotenuse squared. Now the last triangles that we named were being named by their angles. The next set of triangles are going to be named by their sides. So we begin with the scalene triangle. The scalene triangle has no congruent sides. That means that each side length will be a different length. In the isosceles triangle, you will have two congruent sides, or at least two congruent sides. And what happens if you have three congruent sides? Well, now we name that the equilateral triangle, and each side length will be the same length. So PQ will be congruent and equal to QR, which will be congruent and equal to PR. Let's talk about the isosceles triangle a little bit more. The two congruent sides of an isosceles triangle, FG and HG, are called legs. The third side, FH, is called the base. The angle that's formed by the two legs, which is angle G, is the vertex angle, And the other two angles, angle F and angle H, are the base angles. Be sure you have a picture of this triangle in your notes with the congruency marks and with each angle named. This brings us to our first theorem in lesson 4.1, the triangle angle sum theorem. And this theorem is based off the fact that straight angles equal 180 degrees. This is information you already know. So we have a straight angle right here, and we are going to call this line DB. And in this construction, which is the proof of this theorem, they actually say draw line BD, or we can call it DB, so that angle 4 is congruent to angle 1. And the way that we do that, and if you look at these angles carefully, they should look familiar, is by making a line parallel to DB. So now we're going to draw line AC parallel to DB. This creates a set of alternate interior angles that are congruent. It also creates a second set of alternate interior angles, angle 5 and angle 3, that are congruent. Now if you look at these three angles, 4 and 2 and 5, they are three angles that add to the straight angle of 180. If angle 4 is substituted with angle 1, which they're equal, and angle 5 is substituted with angle 3, this means for both the straight angle and for the triangle, angle 2 is also congruent. This is the proof of a triangle that tells us that adding angle 1 and angle 2 and angle 3 equals 180 degrees. Here's our first corollary. This is the corollary for our last theorem. The acute angles of a right triangle are complementary, meaning they total 90 degrees. So we have a standard right triangle here. We have the right angle at C, and what they're talking about is the acute angles, angle A and angle B. Those two angles added together equal 90. And if you take the 90 from A and B and add it to the 90 from angle C, you have 180 degrees. Each angle in an equiangular triangle has a measure of 60 degrees. This is just the corollary from the theorem, and we know that each one of these will be 60, and they will add to 180 degrees. Now theorem 4.1.2 is very important in geometry. You'll use this a lot to solve. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if angle B, and you can see the two hash marks, is congruent to angle Y, and angle A is congruent to angle X, then by default, angle C is congruent to angle Z. This proof is often done by using measures of triangles to prove that they all add up to 180. And when we're using this in a proof, we just state third angles are congruent. So for example 1, we're going to use some of what we just learned, and the third angles are congruent theorem, and solve this triangle. And if you look at the drawing, you'll see we have a larger triangle, and then we also have two smaller triangles. So for this first triangle here, we have angle 1 that we need to solve for, and we have two measures, 36 and 60. So The measure of angle 1 plus 36 plus 60 equals 180. If we subtract those two angles from 180, we have a measure of 84. From previous chapters, we've learned that angle 1 and angle 2 add together to be 180. So we can take 180, subtract 84, and the measure of angle 2 will be 96. On our second triangle that we're going to solve, we now have the two measures that have value, two angles that have values here, and we can solve for the third by subtracting 96 and 45 from 180, and the third angle will be equal to 39 degrees. Moving on, there's things that happen outside of our triangles, and if you extend one of the lines of the triangles, you have a new angle created. This is called an exterior angle. The exterior angle of a triangle forms a linear pair with one of the angles of the triangles. So that means that angle 1 and angle 2 are adjacent to each other. That means they're also going to add to 180 degrees. The remote interior angles of an exterior angle are the two angles of the triangle that are not adjacent or next to the exterior angle. So when we talk about remote interior angles, it's not angle 1, it is the two angles opposite here, angle 4 and angle 5. Angle 2 is the exterior angle once again, and its remote interior angles are 4 and 5. You could keep drawing lines here and make other exterior angles, and they would all have the same properties. Be sure to have this in your notes and label what the name of the angles are. So we have a theorem, theorem 4.1.3, and it goes a little further with this exterior angle thought. The measure of an exterior angle of a triangle is equal. So the measure of this angle right here, XYZ, is equal to the sum of the measures of the two remote interior angles. So these two angles add up to this angle. So angle XWY plus angle WXY equals angle XYZ. And let's do that in an example. So if we take the same numbers, we know that these two angles, the angle X and the angle W, add up to XYZ. So let's go ahead and put that in an equation. Let's substitute the values, and we have 13x minus 5 equals 5x plus 3 plus 64. And using algebra, combining like terms on both sides, we have 8x equals 72, divide by 9, and x equals 9. So you've solved for x, but you're not done. You need to solve for each angle. So 5x plus 3, if we substitute 9, we have 45 plus 3, which is 48. And for the angle x, we have XYZ, we have 13 times 9 minus 5 equals 112. For your homework, you have numbers 1 through 16, 22, 24, and 26. There's an extra credit problem. It's on the last slide if you'd like to do it. And there's also a table here that's in your book that we will actually be going over in class. So I recommend that you put the table in your notes right now so it'll be drawn when we get to class. So here's an example of number 13, how it would be worked out. We are to find the measure of K IH and the measure of angle K. We have an external angle of 140 degrees. If we're going to solve, we probably should solve starting with the straight angle. So the straight angle equals 180. You would take 180 minus 140, and that would make I equal, or KIH equal 40 degrees. Now if KIH equals 40 degrees, you can see we have one congruency remark, one slash mark here, and one slash mark on KHI. Well, that's because these two angles, it's indicating these two angles are equal. So if KIH is 40, then KHI is 40, and now we can solve for angle K by subtracting 40 and 40 from 180. So 180 minus 40 would be 100 degrees, and angle K would equal 100 degrees. Number 24, it says use the figure to find each measure. So it says the measure of AEB is what we're going to solve, and ABE is 78, and BAE is 62, and to solve for AEB, we would subtract these two measures from 180, and AEB would be 40 degrees. This is the table that I was talking about. It's number 41. Go ahead and make a table like this to get ready for class, and we will go over this chart and in a fairly easy way to help you find some of angle measures. And this is the extra credit problem. This extra credit problem is using exterior angle and the exterior angle theorem. So if you have any questions, be sure to contact me. Otherwise, we'll see you in class soon. Have a good day.